Then I think I didn't make any changes to mine at all. So I think, Alexandra, we should, if you could try to share what result you have done so far, and let us have a look at it.
I'll try. Not this one, right? Anything happening?
No.
No. I'm not sure if it's work.
We could also do it.
It doesn't work. I don't know.
No. Okay.
What to do. No.
Then where is my ask? My ask crashed. Or maybe this is you sharing. I'm not sure. No. My ask actually crashed, so I will have to reopen. Maybe it's a general problem with the ask.
I don't think so. Maybe it's with my computer just starting reactions on doing something. I don't know. Looks like it won't be close.
But what we will do is, if I can get my ask to run, you can just tell me what you selected, and we do it on my ask.
This one. Now it should be. Do you see my screen? No.
No, we still don't see your screen. At least I don't. I don't know if any one of you else guys see Alexander's desktop.
Not yet.
No. Okay. Alexander, I think I will share mine, and you just tell me what you have selected, and so on. So I select what you have selected so far. Okay.
Okay.
Yeah. This was the one. Hit it all. And this was the one.
I don't see anything now. I just don't.
You don't see anything?
Yeah, just black square. Maybe you should just my demonstration.
Maybe I should stop share and then share again. But problem is I'm not able. There's something wrong with Teams. I can see.
Yeah, probably.
Yeah. Do you other people? Do you see my Ask desktop clearly?
Yeah, I can see you, Rex.
Maybe I will reconnect to Teams. Yes.
I think you should.
Okay, I will restart.
Let's just wait for Alexander to join again. Always annoying with computer issues. You see, actually, my Teams is also not working perfectly because I don't have any permissions up here. Hi again.
Yeah.
I was swapped to ASK. Can you see it now?
Yeah.
Good. Okay. I assume, Alexander, you have the exact same duty as I have here.
Yeah.
Good. Then I jump to the solution. Okay. Which size of connection did you select?
I selected 65. Yes.
So you already changed the grid to
80. 90.
90 if it's N35. Yeah. Then I will do that. Connection by stream, and then some sort of 65 millimeter. Yes. Okay. Do you have an N35 or do you have a H17?
I have N35.
Good.
But pressure loss is more than 1.5 bar.
Okay. Let's fill in the arrangement you have in the first section. What type of plate arrangement do you have here?
I have played 60-60, and the first one is 4 plates.
Yeah.
4 and 5.
And the last section you have?
The last one, just a second. I have 3 groups, so it's 13 in each, except of the last one, it's 14.
Is it 60-60 or 30?
Yes, it's 60-60.
Okay. So 2 times 13, 1 times 13, and 1 times 14.
Yeah.
Yeah. Okay.
But the pressure.
Yeah, I can see the pressure drop is 1.7. Yes.
Yeah.
But if customer, of course, have specified maximum 1.5, you should aim at 1.5. But remember, the 1.5 was something you assumed yourself.
Mm-hmm.
So 1.7 could be okay. But assuming that he decided that it should only be 1.5, yeah, then we have to do some changes, obviously. But one thing I want to check with this, when going for 60-60 plate, always remember that your CIP flow rate will be higher than if you were going for mix or thermal hard 30-30. Mm-hmm. So the first thing I want to check is what will be the CIP flow on this solution we have selected here. So solution, define CIP, 85. It's not that dramatic. It's 22 cubic meter, so it's actually okay. But if we want to decrease this to 1 point decrease, yes, this to 1.5, what can we do? Yeah, we can add more channels here, but we can also add more channels here, obviously. But we already have a high, and also in this section is here where we have the big pressure drop, you see? But the problem is we have a lot of excess area here. So in real life, this one would be able to cool this down to 25 with this amount of channels. And how to say, the real outlet of the water where he requested 20 will be 23 in real life when this one is operating clean. So it isn't that good. This section is actually, in my opinion, too oversized. So what can we do? Yeah, we actually we can't go less on plates because then our pressure drop will just go up, right? So I actually think we are now in a situation where the best approach would be to change to a H17, where we have less area per plate, so it isn't that efficient. You understand?
Yeah.
So either we can do a new one. I think we should do a new one underneath so we can see the difference between the two. So I go to solution, add solution from current. Change to a H17. Then the stupid program forgets that I selected a wide grid, so we have to do that for the other type. Sorry that I said stupid program, but it's selected 6 bars since we have 6 bar in here. So let us change that to 10 bar. Apply. And let us ask it to reselect. Now it has a 10 bar. Then we need to change the connections since we have warnings on the connections. Where are we? Lady changer, streams. And we select a 65 millimeter and click this one. 65 millimeter. Okay. Then we jump to plates and gaskets. And now it's even worse with the pressure drops, obviously, since the program automatically selected 30-30 as a beginning. So we change that to 60-60. Okay. Now we have a little bit less pressure drop, but we also have a minus in area, so we can add some channels here in order to get this right. So we try to follow the guideline, 11, 12. Okay, that gave us too much excess area. So we go back and maybe say, I don't know, 7. Yeah, let's keep it here with a little bit of excess area. Now we are down on 0.4 bar in this section where we before had some issues with the pressure drop. So actually now it looks like H17 is a better solution than the N35 we tried before. But we have not finalized this section yet. So we drop down to that one and have a look at it. It says 3 times 26. It says 3 times 22. And what if we go in 60-60? It says 4 times 17. I think we should try with this 3 times 22 to start with. So 2 times 22. Last pass is 1 times 22, 1 times 23. So we surround the way. Yeah, we have a CIP flow on around 20, which is perfect. We now have a pressure drop on the way underneath the requested 1.5 bar. We have a heat exchanger which have a cost of 24,600. What about our N? It was 27. So now, actually, we have one heat exchanger which is a little bit cheaper, and it also fulfills the requirements we have set up or the customer have set up. Did that make sense?
I think that yes.
Good. So always try, if you don't meet the conditions you set up yourself or the conditions the customer is forcing you to follow, yet then try with another solution in the same range of size of heat exchanger to see if you can meet it a little bit better.
Mm-hmm.
So now we can agree on that this is the one we're going to quote and this is the one we like. So I want to make this alternative solution a main solution, and then this one will swap into an alternative and I can get rid of that. So I place myself on the solution I want to select. I say general solution data. I change it here to main. Save. And then this one swaps into an alternative, and I can then delete that one by being on the solution tab here. Delete. Do you want to delete this from the local? Yes. So now I have this one as my 2 selection way cooler heat exchanger, which I'm going to quote. Everyone fine with that?
Yes.
Yes.
Good. Then I think we are going to, now we have tried to make one section and then we did this 2 section. So now we are going to try this one, which is your calculation and assignment number 4. We started doing what we are gonna play around with here. We started doing that at the beginning, but now we just want to refresh it. It's a simple heat exchanger, but the difficult part of it is that we have milk cooling as run number 1, and then we have to add a run number 2 cooling cream with half capacity from 55 to 6. So we needed heat exchanger capable of doing 2 different duties. We have some ice water, 2 degrees, and that's it. So if you can all start on this single section, it will be perfect. And I will do it myself without saying anything. I will stop the recording and then do it myself, and we meet up in 10 minutes. We should be able to do one of these in 10 minutes. I'm pushing you now. I hope it's okay, but try to do it. Fine. I will keep this assignment on the shared desktop so you can see it. And I'll remove ASK. And please speak out if you have any issues. Can we start discussing?
Yes, we can, but I didn't finish the calculation yet.
Okay. Did anyone finish the calculation so we can maybe they can share their results? Do you want 5 minutes more? There's no point in me showing each time what I have. I want to see what solutions you come up with yourself, so we can adjust accordingly.
I want 2 minutes more, please.
Okay, let's do that. I don't know what type of heat exchanger what type of heat exchanger did you come up with, Alexandra?
Now I'm trying with N35.
Okay. Bojan, did you have a result, or do you have a result?
Not yet.
Okay. I can't stop recording because my Teams looks funny here, but I will give you 10 minutes more, all of you, and then we will have to look at it. Okay? And I can go and grab a cup of coffee in between.
Okay.
Okay.
Yes.
Yeah. Okay, I believe that was 10 minutes more. So, Bojan or Jelena, do you have something you can share with us? Or is it?
I don't have it. I'm stuck.
I have something. I can share my screen.
Yes, I would like to see it.
Okay. Okay, can you see it?
Yes.
Okay. First, I made a plate heat exchanger for milk.
Yeah.
These are our informations.
Yes.
I choose flow rate for the water, 10,000 liters per hour.
Yes.
And this is my solution. Okay. I choose AH70. Design pressure was 6 bars. So the frame RK6 was okay. And my connections are S40.
Yeah.
Yeah, for milk and for the water.
Yeah.
I choose gaskets NBR detail.
Yes.
Because it's milk.
Yeah.
And then I choose 30-30 plates.
Yeah.
I've made 2 passes. And for the water, I add 1 channel more.
Yeah.
Because I want to that my milk is with water
Surrounded. Yeah.
Yeah,
Yeah.
surrounded. Yeah. Then after that, I made CIP. I choose temperature 85 degrees and my flow rate is 6,000 kilogram per hour.
Yes.
Yes, and that's all.
Okay. So far, it is perfect. No issues at all. The only thing you could argue is, or depending, EPDM gasket could have been used because we have low temperatures and relatively normal fat percentage. So when you are in a low temperature range, EPDM can also be used. So you can use both types. But
Okay.
the actually idea with this one was for you to play with 2 duties on the same heat exchanger. And I can see you have made another item for the cream duty.
Yes.
My idea is that, or my thought was that you should have done your cream duty on item number 5. So you have 2 duties on the same heat exchanger.
Okay.
That was the assignment, but I don't know if anyone else misunderstood it, but that was the idea. So we just played with adding several duties to the same heat exchanger. So if you could try to do that, Delena, that would be fine. So if you put yourself on run number 1, yeah, and you add a duty, and you say original or from current, yes. And then you call that run number 2 or whatever. Yeah, or select the cream.
35%.
Yeah, and the only thing missing now is I think you should change the duty title to cream, so we know.
Yeah.
Yeah.
Okay, then save.
Yes. Then
And now I can go to my solution and here.
Exactly. Now I can see you have understood everything.
Yeah.
That's nice.
Okay, save.
And then let us see what the result is.
Okay, my access area isn't well.
No, it's not. How can you change that? How can we make that more efficient?
Changing the flow rate or number of plates.
Exactly. So first thing, you could try to increase the flow rate of your ice water, for example, on your cream duty. Let's say 15,000.
And yeah, it's in the minus side.
Still minus.
Yes.
Yeah.
So,
Then the only thing we can do now is adding channels, either adding channels or adding passes. What happens if we add channels?
we will change the excess area and pressure in.
Yes, for sure. But there is another impact by adding channels into the solution. And that is that you have now 6,000 liter CIP.
Yeah.
If you add additional channels, this one will go up. So my first approach would be try adding one more pass.
Okay.
So if you just say 2 there, yeah. And then okay.
Okay.
Now we have a lot of excess area in both, but we also have a relatively high pressure drop, especially when we look at the cream cooling. You see, we have 2.1 bar pressure drop on water during the cream cooling. But we also have excess area. So now what I would do, that I would play with the flow rates. For example, on the milk, I would reduce the flow rate to maybe 6,000 liters or something. And then maybe say, I don't know if we can manage with 11 or 12,000 liters on the cream. Could be. Yeah. You see, we went a little bit too low on the milk duty.
Yep. Maybe 8.
At 6,500 or 7,000.
No, it's okay.
Yeah, now it's perfect. That was doing one heat exchanger with 2 duties. Or it could be 3 or 4 or 5 or 6, or you can have up to 18, 20 duties on one heat exchanger. It will just make the calculation function of the program slower, but you can have that many duties on the same heat exchanger. And that is quite normal in real life, that the customer wants to use the heat exchanger for different duties.
Yeah.
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 So this was perfect, Jelena.
Thank you.
Yeah.
And sorry for this understanding.
No. I could have made that clear. So if you could stop sharing, then
Yep.
I'm not sure whether. Problem is that I don't have anything up here. You see, now we have an issue because my teams have an issue with showing the icons in the top of the screen, so I can't actually see whether I'm sharing or not, but I know that I'm not sharing, I suppose. So I might have to drop out and jump in again. 2 seconds. I'm still recording, I can see. Sorry, I think I will now 2 seconds. Maybe I can press this one. I think I have to drop out and then come in again. So if you can go and grab a cup of coffee, and I will see if I can get it working again. Okay?
Okay.
Yeah.
Okay.
Thanks. Sorry for that inconvenience, but it looks like that I'm back and I'm sharing. Can everyone see my desktop and hear me?
Yeah.
Okay, fine.
Yeah.
Then I will find the next assignment that we're gonna have a look at. 2 seconds. First, I want to ask you, so far we have been dealing with cooling, milk, cream, whey. But what I see no idea in us dealing with heaters in these types of applications. The only thing that has to be taken in, you can of course do all the exercises that I sent you, but it will just be duplicating what is already told, except of cooling, we would just be heating. And remember the guidelines we have here, if you're heating to 35 or 33 or 45, you heat with around 5 to 10 degree delta T on top of the temperatures. Some customers require less in delta T, but then it's a special requirement for the customer. But it's up to you if we should do one of the heaters, a milk heater or cream heater. You decide. Please speak out. Okay. Then what I think we should do is we should do exercise 7A. I will open that now, or assignment. Yep. I will just show it to you here. In the meantime, I will close down this one. And here we have it. 7A is a drinking yogurt. But before we start on yogurt as general, drinking yogurt and stirred yogurt, we will have a look at our guidelines. Remember, we are separating yogurt milk, because yogurt milk is the raw milk, maybe up concentrated a little bit with total solids being heated up for fermentation temperatures. That's what we call yogurt milk. But now we are going to look at this. If it changes, come on. Now we are going to look at cultured products. That could be yogurt, that could be quao, that could be Greek yogurt, it could be kefir, it could be labne, it could be iron, every type of fermented product. Typical applications for this type of product is cooling in order to stop the fermentation of the product. Common temperature profiles is in the range of 45, 43, maybe 40, down to 8 to 12, depending if it's set yogurt or stirred yogurt or what it is. It has to be specified from the customer whether it's drinking yogurt, low viscosity, or if it's stirred yogurt, high viscosity. Drinking yogurt can normally be cooled lower than stirred yogurt, simply because of the the viscosity of the product. Stirred yogurt and crowd designs is tricky as it's normally very viscous and non-Newtonian equals share rate thinning products. A quote should always contain a disclaimer regarding product physical properties, meaning that you should tell your customer that you have based it on a stirred yogurt from your database. It's a non-Newtonian product, but it is the standard which we use for more or less every stirred yogurt application. If you have any complaints or doubts about it, you need to discuss with him what do he think his product is then. Do not cool stirred yogurt below 8 to 12, and a temperated water at not less than 6 to 8 must be recommended to prevent high wall viscosity that may lead to structure breakdown of the product. Simply, if you're cooling stirred yogurt high viscous with too low a temperature of your water, you simply destroy the structure in the product, and then the customer don't get the product he expects. So we always recommend temperation loop or a temperated water loop when cooling stirred yogurts. I am still recording. Yes, I am. Typical temperature sets. Drinking yogurt down to 4 to 6. Ice water. Stirred yogurt 8 to 12, 6 to 10 degrees. Ration is 1 to 3 or maybe even higher. And please note here, product sip ration is a lot higher than normal because when cooling yogurt, you need relatively many channels in order to get a gentle as possible treatment of the product. When cooling yogurt, we have to look at plate channel velocity of the product plus shear rate. And therefore we need many plates, or we need more plates in each channel, and therefore our ration for CIP will be higher, especially when we cool stirred yogurt. EPDM gasket can be used if it's maximum 5% fat. A lot of cases, yogurts or what is that called? Creme fraiche. I don't know if it's called the same in the real world. Has a higher percentage of fat, so nitro will have to be selected. So these are the general guidelines for this cooling. Then we have a couple of sketch here, where here we are cooling cultured product. In this case, it's cooled with ice. They want to cool it. They don't want to make a circuit. So they are cooling directly with the ice water. Yeah, but then we can do it in co-current, because then the wall temperature will be higher because the 1 degree are meeting the 43 degrees and not in this end. Or else we recommend to do this temperated loop when cooling stirred yogurts or high viscosity yogurts. Is that clear to all, the guidelines on yogurt or fermented product?
Yeah.
Good. Then I jump to the assignment. You're now going to do calculation 7A, which is a drinking yogurt, 10,000 liter from 30 to 6. Maximum pressure loss on product 0.7 is the requirements on this one. So if you start doing an item for this, and just to show you which yogurt you should select in ASK, because there are quite some in here, I will just show you here. Fermented acidified products. You see we have, oops, sorry. We have this drinking yogurt called APV. If you select this one, then we are all doing the same. So select drinking yogurt APV. Okay. Please go ahead.
Yeah.
Sorry, can you go back to the Excel document, please?
Yes, no problem.
Thank you.
And remember, you just speak to me while doing your designs, and I try to help you, by the way. I'm just gonna come with a couple of comments while you're working. It's not to disturb you, but I want you to try with H17 as your first, and then I want you to do an alternative with O34. I know that I last time said that you were not supposed to quote the Orion type, but I will have to pull that back. I've been told that by product management that we are still allowed to quote it when we are in competitive situations. So please feel free to select the Orion type. But personally, I would stick to the O34, where we have both energy saver and dual flow plates available. Actually, the O34 dual flow is a very good yogurt plate, especially when it's stirred yogurt. On the next assignment, I'm just coming up with a small recommendation on that one. But this assignment with drinking yogurt can be done in normal plate gap plates, meaning H17, N35, or your energy saver plates. But I want you to come up with two solutions, one in H17, one in N35. Was that clear? How is it going?
It's going good. It's going good.
Fine. That's nice to hear. Is it something you want to share with us, or?
Yeah, I wouldn't mind. It's just I'm having port pressure losses. That's the only issue I'm having on my.
Okay, but then let us have a look at how we can get rid of that.
Okay.
Now you went away. Are you trying to share, Daniel?
I can share now.
Please. Yes.
So this is the H17. The only issue I'm having is, well, one of the many issues. However, for the O34, it looks fine to me.
Okay. Let us then concentrate here on the O34 to start with.
Okay.
First, I want to see whether you have entered in the right duty. I assume you have. Yes. I'm astonished to see that you're calculating on the outlet of your ice water. Why is that?
I didn't know the volume. I didn't know the flow rate of the water, so because of the 6 degrees, and I know it can't go over 6 degrees, so I put a 5 degree here, and then calculate the power and the heat exchange rate and the flow rate.
I have to disagree on what you're saying. Sorry.
Okay.
But this is a learning curve. First of all, the temperature of the outlet can be higher.
Okay.
If you lower your flow rate, you see here, actually here you need 72 cubic meter of ice water in order to get an outlet of 5.
Okay.
Meaning that the customer have to purchase a huge pump, right?
Mm-hmm.
So if you set it to, the way I would have done it was that I would have determined the flow rate of the ice water and let it calculate the outlet. So if you put your cursor in the volume flow rate, instead of if you can put your cursor or mouse in volume flow rate in the field? Can you do that?
On
You don't know
this one?
Yeah. Put yourself Put yourself on top of the 72 cubic meter. Yeah.
So, yeah.
Double click. Click. Click.
Mm-hmm.
Yeah, but click. You have to click so you can put in a number.
So what number should I put in?
I don't know, 25. Yeah. Okay, now you have an over determined. Yeah, double click on that one. Yes, fine. The reason for this is, of course, if you use 72 cubic meter and you want a relatively or a reasonable pressure drop, you will need a lot of channels in order to cope with 72 cubic meter.
Okay.
And remember, on the guidelines, if I share again, I will share mine and you share afterwards. 2 seconds. Remember the guidelines. Ration. Up to 3, around 3, maybe 4. Not 7. Not 7 in ration. You had 7 in ration because we have 10 cubic meter of yogurt and you had 70 cubic meter of ice water, right?
Yep.
So now you share again. I don't know if it jumps back to you. Yes, it did. Yeah. Then the H17, we will look on that one afterwards. But let's first concentrate on the Orion. Okay, what arrangement do you have? You have 1 of 105 plates. That will give you around 100,000 cubic meter in CIP. Try to do a CIP, you will see it. You're missing the water temperature, the temperature. Yeah. And then enter. Ah, okay. 70 cubic meter of CIP. Which is too high when we are talking about drinking yogurt with relatively low viscosities or medium viscosities. Another thing, if you go back to your heat exchanger, to there, yeah. If we then look at the result over here, you see your flow regime on this is called MI. If you look, you can see here, it's called MI, meaning that you are below laminar flow regime. You simply will have a male distribution in this heat exchanger. Imagine you have all these channels to distribute the fluid in. It will only run in some of them because you have that many parallel channels. So what you need to do, and you were also told that your pressure drop could be up to 0.7, I believe, 0.8, 0.7. And you only have 0.2 bar on your product, 0.226. So how to change that?
Oh, sorry, I was muted. Apologies. The aim is to reduce the quantity of plates.
Yes, but shouldn't you put in more passes?
Yeah.
Another thing is, it's funny to see that your arrangement guide says 1 of 1,000 plates. What type of pressure drops have you entered in your duty?
The 0.7 is what I entered in the duty.
Ah, okay, fine, perfect.
Yeah,
Good.
so.
Okay, let's see. Your pressure drop went to pressure drop went to 0.9, but you also have a huge amount of excess area.
Yeah.
Yeah. But you also have 50 channels in each, and that gives you I don't know.
What about the plate material?
Yeah,
Maybe.
that's another thing. I noticed that, but I just wanted to come up with something. Yeah, please change your plate material to 316. And your gaskets, I want you to change those to nitro. No. You're doing parts or gaskets. Nitro peroxide. Yeah. I would never go for 0.4 millimeter plates in a food heat exchanger. Either 0.5 or 0.6. Simply because food heat exchangers are open more frequently.
Are open more frequently?
Yeah.
Okay.
For checking CIP and changing gaskets, food heat exchangers are running on a lot harder conditions than industrial heat exchangers.
Okay.
What goes wrong with your pressure drop?
It's exceeded.
Yeah.
On your yogurt side, yeah.
Okay. I think there's one thing where you haven't selected the same as at least me. If you go to your duty, I think you're working with a different product. And then select product. Yes, you should select the one called APV. This one, yeah, fine. Okay, that changed dramatically then, the pressure drop. You see, it went from one, I don't know, 1 bar down to 0.5. You still have a lot of excess area. You have 38%. So you could decrease that. You can see actually now it's coming up with a reasonable guidance. You see now it says 2 of 25. Before it's with the other product you had, it said 1 of 1,000. You understand?
Mm-hmm. Yep.
Okay, now you have 0.71.
Yeah.
What about your CIP? How does that look? That's okay. The only thing I think which should be changed on this, if you go back to the heat exchanger, I can see you have selected, as far as I remember, you selected 100 millimeter connections for only 10,000 liter of product.
Oh, yes. It's changed. No, it's not.
So if you select the smallest possible you can get from an Orion, please do that. No. Sorry, one thing. Stop. Stop. When I know yesterday we moved around in this because we want to have some extra connections and so on. But the easiest and most understandable is to use connection by stream up in your left corner. Then you don't make any mistakes. Yes.
Is the cheapest one by?
Let's say this is for UK, so it has to be British standard. So you have to find some British standard connections. Oops. Yeah. British standard BS. Yeah, this one.
Okay.
What happened here? It is not able to select the same type. Try to do a complete union and see what happens. You have a male part. If you try a complete. Stop. You have one in the middle. You have one called welded union. Yeah. Yeah. And then do the same on the one above. Yes. Okay. What went wrong here? Let's recap. What went wrong here? First,
flow rate.
Flow rate on your ice water. I always, unless it is specified by the customer inlet and outlet temperature, I always determine the cooling water flow myself.
Okay.
And let it calculate the outlet of the water. That was the first thing. Next thing was that you didn't select the same product as I did. And then you were sort of just looking at doing the performance without thinking about CIP from the beginning. You know what I'm saying? And always think about, okay, I have 0.7 bar available. So I can do it with less channels and then have additional passes. And when I have less channels, I will lower my CIP flow rate. Okay. So now I want you to play with your H17 and get that one right. And then if you stop share, I share again. And you just play with the H17 and get that one right. loops. Did everyone understand the things we went through on this one? I don't know if you made the same, sorry, Danielle, same mistakes as Danielle, but it gave you a picture of how to approach it. Do you all understand?
Yeah.
Yeah.
Good. We will today not manage because it will take some more time to do assignment, the next assignment, which is the stirred yogurt one, because they are more difficult. So what I want you to do to next time is to get the H17 and the Orion right for this assignment 7A. For this assignment. So you get your item 6 or whatever item you have, you get that right. Or something you believe in, then we can, if you have doubts about them, we will discuss that next time. And your home, that is one homework. Other homework is this task or calculation here, 7B, which is a yogurt with 12% total solids, cooling from 30 to 15. This is stirred yogurt. In the program, in ASK, for this assignment, you should select, I show you, you should select this one called stirred yogurt 15% total solids. This should be the product you use for assignment 7B. That will be your homework for next time. All clear?
Yeah. And Niels, do you just want one solution then for that assignment?
Yes.
Yeah.
You can just
Okay.
do one solution. Yeah.
Okay, perfect.
I just have one recommendation for you. And this is just to give you some guidelines. You remember, stirred yogurt, in order not to disturb or damage the structure of the product, you have to be in this range of plate channel velocity, somewhere in this range. And your share rate should be around 200 to 300, maybe a little bit more. This is simply to have a gentle as possible treatment of the stirred yogurt. So if you're in doubt when you start doing the designs, open your presentation and look at the guidelines we have here. Okay. Also remember the guidelines up here about temperation loops. We are now cooling from 30 and not 43, but doesn't matter. Are you confident in doing that assignment or any further questions to it?
Can I ask a question about 044 heat exchanger?
Yes, please.
Can we use the DuraFlow plates type or
Yes.
server? Which one of them?
For a stirred yogurt cooler, I would use the 0034. Now I'm actually helping you. I would use, and that's the point also, I would use the DuraFlow plate for sure.
Mm-hmm.
Either the 0034 DuraFlow or the Q030 DuraFlow. That's the two plates I would use for a stirred yogurt because we need a gentle treatment, so more plate gap.
And for drinking yogurt, this the same or just
No, for
not?
drinking yogurt, which is where the structure, the rate of damaging the structure is not the same. So for drinking yogurt, I would use a normal gap plate. And that could be Energy Save or N35 or H17.
Okay.
Yes?
Thank you.
Okay, that was all for today. And I will leave it to you to finish up this one, assignment 7A. And then for next time, you should have done assignment 7B. And then we will look at the results you have.
Okay, thank you.
I wish you all a good day.
For you the same.
Okay.
Thank